Hello everyone, it is August 10th, 2022, and we're doing a live coding stream here on Twitch. Thank you all who could join us today. Still getting started here, so people are joining. And we have Odinson in the chat. What's up? How are you doing? Hello, test chat. Let's just see if this works. Yes, it does. All right, everything's looking good. Hope everyone's had a good week so far. It is, what day? It's Wednesday, right? It is Wednesday. Need to remind myself of the time of day. But we're going to be streaming here and doing some data science stuff. I kind of have a few things in mind, but I want to let chat give me some suggestions as to what we should work on, if that sounds cool to you all. Let me make sure I get my screen set up right. That's always important. And Odinson, if it's just you and me, then your chat, so you get to decide what I'll work on. Does that sound good? Okay, let's try switching to this. Okay, there we go. Oh, this is a little bit zoomed out. Move that. Let me do this. Where you get to see the side. That works. Okay, so enough excitement stuff. Hey, what's up? We have someone else in chat. We have Ostrinica. What's up? Welcome to chat. How are you doing today? Just getting rolling. So I'm on the Kaggle website, and I got an email. You all might get these too, but I got an email saying the competition was ending, and it just felt like yesterday that this competition started, and I never even looked at it more than, I guess we did a starter notebook on it. I live streamed. Let's see if there's any of my work. Yeah, we live streamed this EDA notebook, but it's only got 24 hours to go. You're working yourself, Osnika? That's awesome. So we were looking at this competition before, and a lot has probably changed since then, but the goal of this competition on Kaggle was to, or is to, for 24 hours still, is to figure out the order of notebooks based on just the content. So I forget what the scoring metric was, but the top people on the public leaderboard are at like 0.95, 0.94. I don't think these are overfit. I'm just guessing. I don't know, but these people, I recognize some familiar faces that are definitely good at what they do, and I don't think that they would submit high scoring submissions unless they actually thought it would work on the private leaderboard, which of course we won't be able to see until tomorrow. I can say it as Ostrinica. Ostrinica? Hopefully I said that right. So I just want to see what the best public notebook is for this. The pivot private leaderboard will be from future data. Oh, it's one of those competitions. So we don't know what the private leaderboard is going to be like. Best scoring notebook. CodeBert plus pairwise. What's pairwise? This notebook demonstrates a simple ensemble mesh method for ranking problems. It's based off the Two Incredible Notebooks. So this is like a combination of other notebooks, but it looks like BERT small inference. What's pairwise? BERT small pairwise. So I don't know how much I should try to understand this competition since it is ending soon. But I am kind of interested to see at least what publicly is best. So then tomorrow when we see the private leaderboard. Close, you'll be listening while you work. Okay, so I just want to see at least what's going on with this one. Stronger baseline with code cells. So CodeBert. I think we looked this up before. So this is like a BERT-based transformer model trained on a bunch of code. So I'm assuming that like the vectorized text takes actual code in. This was trained on 6 different languages. I'm guessing most of the notebooks are just Python. So the tokenizer is specific for coding languages. Gmax, what is this? Oh, that makes sense. That the tokens would be stuff like this. New lines, tabs and stuff. Okay, so this is like, it's kind of like Google Copilot, or not Google Copilot, GitHub Copilot, where if it's trying to predict what code you want to write based on text, that's probably a little bit different. Graph CodeBert, this is probably like doing graph interactions between the parts in the code and how they interact. Like when you call a function somewhere in your code, it's referencing. That's interesting. So let's just see what the base notebook looks like. This reads in the notebook. So this just basically reads the JSON. And hey, how's it going? Do we have a new follower? We do. Bezuux. Welcome to the stream. Welcome to the family. Hello. Hope I'm having a good ETSW. I am having a good evening. I hope you're having a good one too. WordNet Lamentizer. NLTK. What's the WordNet Lamentizer? Lamentation is a widely used text mining. Text mining is extracting high quality information from natural language. Let's actually read the documentation from NLTK. Lamentize using WordNet's built-in Morphe function returns the input word unchanged if it cannot be found in WordNet. Oh, so is it like correcting for misspellings? Or making it standard. What's on today's menu? I don't know yet. Bezuak, you're studying right now? You're studying this right now. Oh, are you in this competition? Okay, so CodeBert. So what does this do? Pre-processes the text. So it basically just replaces any... Well, what does this do? Make everything lowercase? I don't know what I'm not very good at regex. Oh, it says in the comments, remove all special characters, remove all single characters, remove all single characters again. Oh, this is a unnecessary bit of redundancy. Lowering all the text, that makes sense. Then does it just do this over and again? This is the exact same line, right? This text just repeated. Then this is the validation. So it takes in all the text, torch no grid, takes the model in. Where's the model? Oh, that's given in this. So we need to see where the model is. Markdown dataset. Markdown dataset. Max allowed by the model config. It tokenizes from a pre-trained model. Then when it gets an item, it tokenizes it in code plus. Batch and code plus. Blech. There's a lot of stuff going on here. Attention mask, long tensor. Now it's called a markdown model. Is that because they are separating out the markdown from the code cells? Markdown is just an auto model from pre-trained. So we need to see where that markdown model is created. In the model path is the code BERT base. Okay, so that makes sense. And then these are just trained code BERTs. And this is where it predicts. And it's doing it. Okay. Congrats on the 7K subs. I appreciate it. Yeah, we hit 7,000 YouTube subscribers and we're hoping to go up from that. So what I've been doing also is, or what I did for the first time since I first started streaming, I had put up some of my streams and then I took them down because I felt like they were just, you know, weird to be putting up, and I felt like no one was going to actually go and watch them. But I just figured to give it another try. So I uploaded one of the streams from a few weeks ago, a little over a week ago, and now we are recording today. So I'll see if today is interesting at all. We can upload it. Okay, so this is what happens for big competitions too. It's a lot of the top notebooks are all the same idea. This code BERT plus pairwise. And people are tweaking these so much that they're probably just a little bit overfitty. But it is what it is. And then everyone just copies that code and submits it themselves, like I have in the past. I'm not too proud to say that I have never done that. Okay, so on the docket tonight, I have a few different ideas. Let's talk about what to do tonight. We could go back and look at, are there any new competitions? I think there's a new tabular. I've never really looked at the tabular playground series in depth. We could look at that. There's this cervical spine fracture detection one. And I was talking about how my vertebrae have been fused, C6, C7, and I could probably get my my CT scans or whatever scans they were for that competition. But we can look at, what I'm thinking is we can look at the data shootout. I have some ideas. I want to show you the chessboard piece detection. Then number 3 is we can always do is try to create a new Kaggle data set. And number 4 would be create a notebook for my existing data set. Try to get some hype for those Kaggle data sets. Just in case you didn't know, on Kaggle, I'm trying to become a datasets grandmaster, which has actually been one of the harder things to do on Kaggle. So I have 2 gold medals, 4 silver, and the way you get these is by getting them. These are awarded by the number of upvotes you have. So a lot of these we worked on during the stream. The exchange rates, actually all of these. Let's sort by most votes. This hourly energy consumption I worked on 4 years ago. But other than that, we made this parquet format, I think, on stream. This was the first thing I streamed, was creating these roller coaster data set. Exchange rates, I don't think I did the NFL helmet one on stream. Maybe not the Reddit place one. But most of these, we took a whole stream to make the data sets. So they're not as popular as I would have hoped. And I'm trying to make them more popular and more looked at by maybe creating some more notebooks on them. I don't know. I also made a Twitter thread that was pretty popular talking about all these different notebooks. Still no upvotes. So that's what I'm thinking is that these could be our things to do. Now for the chessboard piece detection, I was running object detection on this and it totally made me rethink what I've been doing with my life or what we've been doing on stream. So let me go to our chessboard vision. And actually, no, let me go to YOLO V. I did it on V5 and V7. Runs, our detect run. Let's open this. And it was, I think, on 143. No, because this doesn't have. Yeah, this one. I've been trying to see if I could get a chessboard object detection. And it made me think there could be a totally different way of approaching this. Maybe I can make my object detection better by actually taking pictures of each. This is just me showing YOLO V5. Here we go. These are all the different pieces. So we could work on this and try to improve this by creating more images. And I was actually thinking we could create something that simulates the board setup based on the images we take of each piece. Hear me out. I think it might be a cool idea that could create some training data set that we could then train a deep learning model on. So that would be number 2 here on this list, chessboard piece detection. Data shootout Kaggle competition we worked on before, but we could look more into that. I haven't really looked at it since I streamed last. And then create a data set and create it. So let's make a poll on this. Kaggle dataset, and let's make this poll 5 minutes. If you're in chat, feel free to vote on any of these. And let me know why, or if you suggest something else, then we can work on that. Kaggle dataset, okay. I'm gonna need people's help and suggestions for what we should do with the Kaggle dataset if we do that. I'm gonna submit this. All right, so Kaggle dataset. People want to work on that more than chessboard, more than data shootout. Fair enough. Fair enough. I'm sorry. Did you answer my question? My internet is bad, misconnection. Oh, what are you saying? Are there any kind of stuff about lottery? Oh, Kaggle stuff. So ETSW, are you saying like make a data set that's based on lotteries, where the lottery winners are? What do you mean by that? Like predicting where the lottery winners will be? ETSW, I need a little bit more info in order to answer that question. It looks like the Kaggle dataset is going to win. You guys are forcing me to achieve my goals instead of being distracted. Predicting the location and winners would be cool. But isn't it just random? Why would we want to predict something that's just, in theory, it's supposed to be random. Now, I know that they have like proof that lotteries, at least the scratch off things are won more often by people who own or family members of people who own establishments that sell those tickets. Moomy is voting on some distractions. You still have a few minutes for people to vote. This thing about doing the voting right off the bat is not everyone's in yet. So I'm new to this as well. I don't know how to use Kaggle up, but I like to learn with you. So let's say we want to do something about lottery, and I will search Kaggle, what are search menus, and reach out to ideas on Kaggle. Okay, so let's think this through. On Kaggle, we could like plot lottery. This is just people talking about if a certain competition is a lottery, like just luck based. Singapore lottery numbers. So there is some lottery. The thing is, I don't really like gambling too much because I know it's just the odds are not in your favor to win. Is it truly random? That's what this person says with their data set. Fully comprehensive data set of lottery draws, winning numbers, breakdowns, odd evens, ranges, monetary prizes. The player choose 6 numbers. I mean, that's pretty interesting, but I think it's going to be random, right? One idea I did have for datasets, and this is kind of off track, and let's see if datasets is still winning. By the way, still vote in this poll. I think it's still up. Where did my poll go? Here's a poll. Still going for Kaggle dataset. So, one thing I was thinking about is like popular names. New York City, popular baby names in New York City. But what about just overall name data set? If we made like this would be like US probably specific. But we could try to figure out popular name database. Oh, this is a government website with the from Social Security with names and their popularity. We could scrape this. This could be interesting. All right, so yes, but of course NBA dataset is your hobby. Oh, so one is small features and where you can do about it besides looking at counts. It has a lot of features which you don't know what to include or how to use it sufficiently. Yeah, I'm not sure about the lottery one. I guess there's like an optimal time to gamble on the lottery. Like there's a time when I heard a podcast on this. There's a moment when certain lotteries become actually hot. Like it's sort of like counting cards in blackjack, where you know if no one's won for a certain amount of time, now you've reached the point where the deck is hot, or where you're gambling on this lottery is actually you could put in enough money that your odds of winning are worth risking your money. So then people will find when these situations occur and they'll just buy up all the tickets, or they'll buy up like majority of the tickets. So how do we get this data set 2010s. So here's the top names in 100 years. Let's go ahead and get a notebook started up. So let's go into Twitch stream projects. Make a directory called 046 baby names popularity. And then we're gonna conda activate Kaggle 2. And why don't we go ahead and do this? I need to make sure that this camera is actually beneficial. Maybe actually will never be. And I should stop using it, but let's keep on trying. All right, so we are in my Kaggle 2 environment. I'm gonna open up Jupyter Lab. It's gonna load up on that. This is something else I've been working on. My Pandas Noobs. All right, so Twitch. Oh yeah, the filtering does not do Twitch. Twitch stream projects, baby names. Let's go, new notebook. We're calling this baby name scrape. Baby name popularity. The funny thing is we call it baby names popularity. That's what all these sites say. But aren't they just adult names too? They eventually will be adult wins. It only works if no one else gets the same idea though, because both of you win, you have to share. That's true. That's true. Let's see if I can find like if I could see what I don't want to read all these. No, there's a bunch of articles about cracking it, the lottery, but they're probably all just scams. Okay, so this site, like we could read just this. Read HTML for this. Made it. Let's see if this works. Wow, that's taken a while. See the limitations. Beyond the top 1,000 names. Oh wait, there's just state-specific data, territory-specific data, national data. This is what we want. Yeah, let's make a script that pulls this. So let's stop what I'm trying to do here. Let's stop that. Let's go back to the terminal and let's do this the right way. So let's go to the directory that I want to be in. And then I'm gonna, let's make a new tab. Oh, this can just start me out here. Twitch, 45. Let's make a shell script that's just gonna wget this, wget this one, and wget this. And then it should unzip all of these, right? Let's just get them first. Chmod this. All right, it's downloading. It's connecting to ssa.gov. Why is this so slow? Do I have a problem with my internet connection tonight? Hopefully not. It's like it doesn't want to give it to me. Do I need to do something special to download this? No, it's downloading if I do it directly. Maybe try HTTP. Oh, good idea. So the thing is, I just pulled it into my downloads directory. So if this doesn't work, I can grep names. It's already here in my downloads directory, but yeah, let's try to delete the S. Thanks for this suggestion, Cheeto Bandito. Best name on the internet. No, it's not working. Well, at least we know that's where we're gonna download them from. Let's just give in. Let's not be too purist about this. So let's move these files. So in my download directory names, I'm gonna pull that over here. What were these other ones? Names by state, names by star, and I'll move those here. Now we have these. Oh, I'm in the wrong folder too. Should be in 46. And then we'll move this also. Now we're in the right folder. Now we're gonna unzip the names. That zip. Unzip. Of course it made him all here. So let's make a directory. Let's remove star.txt and remove this national readme. And now let's see if it's clean. Let's make a directory called names. Make a directory called names by state. Make a directory called names by territory. Let's move names.zip into names. We might just want to move these into a Kaggle data set very quickly and then do our work in that. And then move this names by states. Now we are going to want to clean this up. This is weird. Maybe they're sniffing the user agent and blocking wget. Is that how it works? I don't know how it works. I just know that usually up until today, I could just wget files and it would work. Oh, look, they have a different file for each state. So let's take a look at this. Let's take a look at my home state, Maryland. I wonder what these numbers represent. Maybe we have to read this PDF. Let's read the README. State-specific data on the relative frequency of given names in the population of U.S. births. For each 50 states in the District of Columbia, we create a file called sc.csv, where that's abbreviation. Each record in the file has format: 2-digit state code, gender, and the 4-digit year of the birth, and then the 2 to 5 character name. 2 to 15. The number of occurrences of the name. Fields are delimited with a comma. I like this README. It's a very clean to read, but we're gonna not keep their formatting because it's a horrible format. I'm being a little dramatic. But we are going to fix it. We are going to fix it. So we did the states, and then I don't know what the names by territory means. So let's unzip. PR and TR? What's PR? Oh, Puerto Rico and other territories. All right, can't forget about Puerto Rico. I'm not sure why you just didn't. I guess they're not technically a state, so they didn't want to. Let's import glob here, and then let's get all the states. Or should we just start with start from the beginning? Let's start with the names data. So these look like they're in the format year of birth and then the year. So if we look at 2021, yeah, this is not broken down by state. So it should just be an aggregation. It should be an aggregation of the other data. I'm surprised this is not on Kaggle already, which I guess is a good thing for me because that means that doing something right. All right, so these are the names, right? These are our name files, people. Ask me questions if you have any questions about this. So we have our name files. We use glob to pull in the name files list. Then we could like go to the first one and we should just be able to read CSV because even though it's a TXT file, it is comma separated, right? Oh no, you found it? Yeah, it already is up there, right?
Hi, I am Gregor.
Moomy, why is it always existing? The thing is, the person who created this data set did nothing more than just throwing
All systems ready.
a bunch of files up there. They didn't do any of the cleaning stuff. So let's just continue on with this. I like watching the manual method. What manual method, Cheeto? All right, so header is none, right? Columns, can I give it the columns? So this is name. This is, what do they call this?
Drum check. Status check. Melody check. Draw sequence loaded. Start the countdown. Hi, I am Gregor.
They call it sex. For gender, yeah. Okay, so name, X, and then count. I think count is correct.
All systems ready.
Let's just call this DF. It's probably not the best way to do it. I don't know if I could. Maybe I could actually.
Let's check the systems. Let's check.
I'm going to also load in lab black, which will do auto formatting for us. So I don't know if I could have set the column names as I read it in when the header is none. Oh, maybe I just give it the header is the list.
All systems ready.
Must be an integer or list of integers. So that's not correct. All right, so we have this data frame, right? Then name files also has the year in it. Oh, it's names? You're saying it's like this? There we go. I knew it was there. Do I have to do header as none? If I put in names, then I don't. Okay, so this is much cleaner. Thank you, Maddie. You got my back. All right, so this data frame here has all the names count, but it's for this year, which is 1997. And we could just do like a something like this, which would get us the year. And it should be an integer. And then we could do this. Create a list of data frames that will append. Right? And this is going to be reading in the name file, which is we're calling F now. Just out of curiosity, why the Cubone shakes so much? It shakes because it's actually on my desk. It's like linked to my desk. So I need to figure out a better setup. But Daxer, thank you for mentioning that. Now I know. And I can turn it off too if it's annoying. My fingers are jacked. Yeah, it's showing how strong I am. So what are we doing here? We're looping through each of these file names and we are saving them and we're appending them to this and then our PD concat dfs, right? Now, if we look at this data frame, it has every name, the gender, the count, the year. There we go. So that's our main data set. So we're going to have 3 files that we'll end up having here at the end. And we'll upload it to Kaggle, even though there is already a names data set. But this one's going to actually contain a single file that I think will be a lot cleaner for the users. All right, so year. Like if we go to year and just do a value count, there should be a similar number. And let's plot this. What's going on here? Sort index. Let's get a different style sheet. So we're getting 538 style sheet. We're plotting this here. Let's also get a color import Seaborn as SNS. Color pal is going to be this. I think that's how we do it. Yeah. Now we can give this bad boy a title that's names. This is unique names per by year. And set Y, or maybe it's Y label. Number of unique names. It is set Y label. And then this is obviously year. What do we see here? It's the Stallion Jigaman. Welcome to the stream. How you doing tonight? And of course this camera's off. Every time I try to fix it, I just make it worse. Story of my life. Story of my life. There we go. You're doing awesome. Nice. How's the new job, Jigaman? All right, so now we have a single data frame that we should actually call names. two CSV names combined. Let's just call this our master names. Index equals false. Now I do want to test some names. I need some names in chat that we can look and see the trends of these names. You're finally doing what you're supposed to do. I'm so happy for you, man. That's awesome. Let's test some names. So this is where name equals Robert. This is my name. Set index as the year. Oh, we have both genders. Okay, so how can we do this? Group by the sex and the name. Unstack that. I guess I just do a group by this and plot it this way. So this is gonna be like this. Group by and then plot sort index. There we go. And we're gonna want this to be on the same axis, so let's do it this way. So we'll plot both of them. We'll plot each of them individually. We won't do this group by so that we can actually give it a specific color. Oh, and then I need this. Let's make this a little smaller. There we go. That's a little easier to see. So it kind of is silly to plot the female count here because no one's named, very few are named Robert. I'm so sad I chose Kaggle Dataset at a poll, but my internet was gone for a while and I missed what you did so far. Can you summarize quickly, pretty please? Yeah, so I found that I was thinking about baby names, and there's the Social Security Agency in the US that has all the historic names and their popularity. And then it also has it by state. So we can kind of do a geographic analysis of names and when they were popular and where they were popular. So I kind of want to not even plot the female stuff. I guess we could do this. We could do this. All right. So I know I keep on going back and forth, but let's do this. Label as male. Don't know why label's not working. And then let's do twin X. This would be axis 2. We can always plot like this. And this will be on axis 2. All right, so color is, let's make this different color. And then we can make the legend male and female. Remove this legend. And why does it only show one? It's because I split these legends. I'm so sad I chose this. Oh, nice. And if we combine the solution with election votes, we can generalize with both names at the part. I guess so. Okay, so let's just forget about this label because we know. Let's try to get like a pinkish. There we go. So the red is female names and the blue is male. Hey, thanks for the follow, Bubble Brain. What's up? Let's make this name a variable. So that we can run this multiple times. And make this an F string. All right, popularity of the name Robert, both male and female. Interesting. I thought that Robert was the most popular in the 20s. But I'm proven wrong by this data set. Every night I stream is a blessing. Thanks, Jigaman. Having you here is a blessing. Increase the height. Okay, so the reason why this legend's acting all messed up is because... Let's Google this. I'm sure someone's asked this. Matplotlib, data being plotted over legend when using TwinX. This is what's happening to me. No, that's not exactly my issue. Oh, you can do Fig Legend. So they're saying to not do this. Remove these legends. Fig.legend. Yes, there we go. The music's good tonight. Nice. I hope I don't get... When I put my stuff up on YouTube, I usually get like a copyright strike for music. So I hope that this doesn't get it taken down. All right, so this is my name. My name's popularity peaked here. I was like named Robert here, which is like right before it started fading away. And I guess being named Robert as female, so this is like the right axis, was never anywhere on the same scale as male. Crazy store in DC, Methlin. Yes, we had our power go out twice today.
Initialize data.
So, are you in the area?
All systems ready. I am now online. Activate.
All right, so this is going to be a function now. Plot name function. Plot name Robert. Yeah, it was just a bad thunderstorm. Power went out for a few minutes for me and then went back on, so I wasn't too upset about it. But it is kind of crazy when it's that wild out. And I went on a run after the storm, and it was still kind of grumbling. And I was thinking to myself, was it dangerous to choose to come out here? All right, let's talk about some other names. What other names do we want to look at the popularity over time? Let's look at Karen.
All systems ready.
The name Karen. So I know they said the name Karen really went down in the most recent years. So let's also have this take in the data frame, which will be like so that we can subset it.
Let's check the systems.
So like if I do plot name, I do DF and I do Karen,
Synthesize
and it won't work if I do
baseline check. All systems ready.
So this is just the female, but then the twin X is going to make it on the right side. And it still has this legend. But let's also only look where the year is, and year is greater than 22,000. So surprisingly, I know it went way down in popularity, but it was already trending that way. When did the phrase, when was it coined, like, to be a Karen?
20%. 40%.
You wonder percentage of John and Jane that comes from not being named by the authority? I don't think that's how it's named at birth. Don't they give you John Doe when they don't know who that person actually is? Like they commit a crime? Or there's some anonymous person that's reporting. What's another name you want to look up? What's like a popular character? Hermione? What's her? No, Harry, like Harry Potter. Did that become popular after Harry Potter came out? So the female names is kind of like not worth looking at, but 1940 it peaked. No, it doesn't look like it really had much of popularity. Is Daenerys in there? There we go. Let's look up Ralph. Good suggestions, y'all. We should have this actually do male only, like. So if the length of genders is 1, we will just do this. No, if the length of genders is 2, we'll do this twin X stuff. And then we'll have this legend be genders. This way, I think it'll be a lot better because we can provide it if we only want male or female. The coloring, though, I think will default to the blue. All right, so this works. It just has M and F. So this one, if we wanted to do genders is just an F. Okay, so we want this to be gender 1. So we could give it the different order if we want, and then this will be gender 2. Can I just do it like this? That's right. We want this to be gender 1. If the length of this is 2, then it's going to go like this. Making this all way too complicated. But now our code can run for just the name Karen, and this is year 2000. Let's just do the year 1990 on. It's been going down. Now the name Ralph. Wreck-It Ralph. Just M. There we go. Ralph didn't have a resurgence. Everything's going down. Do people name their kids after athletes a lot? Like Michael's? Okay, let's look up Michael. Well, actually, before Michael, people have been saying Trinity, Morpheus, Thor, Charlotte, Daenerys. Let's see if this, and this will be for a female. No Daenerys. Nope, no Daenerys. I think it's only the top 1,000. So Linda was the top name of all time in a single year. Linda went crazy here. What is this peak Linda? When's peak Linda? Peak Linda? We can find this out by doing name is Linda. Sort values by count. Ascending is false. 1947. The late 1940s, early 1950s. Linda was the name to be. Look at this. This was the Linda streak. These were the years of Linda. Charlotte, Felicity. We can do all these. I guess it's not that impressive. Wait, Charlotte went way up. What happened with Charlotte? Felicity. Little ups and downs. Wasn't there a TV show called Felicity? Thor. This is going to be an M. David said, how about Tidyverse? No, thank you. Is there American Idol that parents name their children on them, like Elvis? Elvis, look at this shoot up when Elvis' name was in popularity, when the famous Elvis came into prominence. Let's try Michael. Michael, yeah, Michael's always been a kind of big name, right? It would be cool to see compare two different. Dakota's a good one. That's a good female name. Check out. Yeah, Dakota was like nothing until the 90s. I didn't know that. Wasn't there a song Delilah? I don't know what it's like in US, but in Argentina, it's very common for people to name their kids after athletes that make big impacts. Yeah, I think that's true here too. That's probably just like a phenomena. Delilah, yes, that's right. Hey there, Delilah. Whoa, Delilah. When was the song? So when's peak Delilah? This came to my mind. Can you look at the name XAE? No. No. I know what you're trying to do. Is that some sort of thing that'll make my... Oh, wait. That's Elon Musk's son's name? No way. It's only the top 1,000, so I don't think this name's going to be here. I didn't get the reference. I had to Google it. All right, so we have the names data set. I think that's pretty good for now. Now let's look at states. All right. Remy said needs 5 minimum. Oh, okay. So actually, let's do, yeah. If we look at it, if it's the top 1,000 or not, that means that there were less than 5 Daenerys. Because I feel like Daenerys was a pretty popular one recent. Let's start this music. So we saved this as names. We made the plot names. Now we're going to go by names by states. Oh, it's not in input. It's in names by state. And then let's also add in names by territory. I feel like there's no reason to exclude those. It's just these two territories. How'd the chess piece recognition program turn out? Plyo, it's still in progress. I actually wanted to talk about it on stream today, but we voted against it. We voted to create a data set instead of look at the chessboard. But I will show you, I'm gonna make a YouTube video about, not it specifically, but about YOLO V5 and YOLO V7, where I was running, not this one, this one, where I was trying to detect a chessboard. So I do have a chessboard set up here that we can run this on pretty soon. Are you shaking your leg just like all of us? Oh no. So it shakes a lot because of my leg? That's why it shakes so much. Let's just take off that camera. It's just gonna be a distraction now. Yeah, we're gonna do the chess stuff. I have some ideas about what we can do with that. My ideas are to take the pieces and to take a video of each piece at different angles and then train the YOLO model on each of those pieces. Because right now the problem is the data set that I trained on only has a very specific angle that it looks at each of these pieces. So that's my thought. That'll probably be a lot of grunt work, but I think it'll work. I just take a green screen background. So I have like a green cloth. So I can extract out the background. And then I take like my iPhone and I go to each piece and I like just, that's a bunch of pictures basically if I take a video. Man, now I want to start doing that. Jiggaman, you're liking the music. I like it. Is the volume okay? I'm always a little worried about the volume being too low or too high. All right, so we're basically going to run our same concatenation, but let's break here. Yeah, so it is going to break. I expected that to break. And then let's look at this data frame. Oh, how does it already have OR as the index? Let's look at this file. Names by state. All right, so it already has the state, gender, year. Yeah, this is, so we just need this to be like this. State. What is it? What's the format? State, gender, year, name count. And then this needs to be oh, we don't need to add this in because it's already there. I think this is good. Okay. States. There we go. All right, so now what can we do by state? We could plot all 50 states for a name. So if we do like name equals Robert, set index as the okay, I think I got this. And then we can set the index as the state and the year. Oh no, we want to group by. No, we want to set index and then unstack like this. What will this do? This will give us each state as a row and each column as the year. Do I use Spark often at work? Not really the back end stuff. We use something called Athena, which I think is like distributed queries on Parquet files. It works awesome. So can we plot this? So now each year this is wrong. We want this to be year and state and unstack it that way. All right, so each state kind of is different. So nice, AWS. But what about handling of the data when it's brought into the data lake? Are they using Spark? No, we don't use Spark. It's the data that I'm working with isn't that large. And it's kind of, there's no need to do large queries across stuff. And when we do, we use Athena. Like the data that I work with is large in the sense that like the files, video files are large. A lot of different data sources. Let's import Plotly Express as PX. So if we do PX line for this, what's this going to look like? Okay, so this is a little bit easier to read. Now we can filter each state specifically. Heat map for name for each state with color of count. Oh, that's a great idea. ETSW. Let's try that next. One thing I want to do first is, should we have like a normalized count by state? So if we like group by, let's group by state, sex, and year, and do a count sum. This will give us the total for that state and gender names. And then we can do, then we can map this we can merge this on And let's validate that it is 1-to-1. It's not 1-to-1? Keys are not unique in the left set. Why? How is that possible? State. Oh yeah, it's not going to be unique in the left data set because it has a row for each name. Okay, can I explain what normalized means in this case? So yeah, so I'm trying to get like for each year for each state, because some states are just larger than the other ones. So what we're seeing here in this plot is New York is at the top for the names, not because it was the most popular name in New York, but because New York just might have more people that are born. So if we normalize this, it's sort of like the rank. So another way to put it here is the count of this name for that year divided by the total. But I'm choosing to normalize by the state, gender, and year, but I could also just do it by the state or the state and gender. So let's try to plot this one just to see. Count normalized. Oh yeah, we're gonna do this same count normalized here. Count normalized does not exist. Oh, that's because this is called states. I shouldn't have been doing this. Calling things the wrong name. Why is everything 0? That's not right. Oh, I'm casting it as an integer. There we go. Now we have kind of a different problem. The ones that are going to be floating all around are low populated states. So especially back here early in the 1920s when no one really lived in Arkansas, there it's going to be just like jumping around. But it is interesting to see that Rhode Island was really popular with the name Robert. Is that because of the Kennedys? I don't know. Wait, what is this? Delaware went up? Put a threshold. Let's find this really high one. This says 12% in 1920 of Nevada. So let's pull states. Query state equals NV for Nevada. And males. Sort values by the count. Let's pick this year, 1921. And year equals 1921. Yeah, there just weren't that many people. So it says in Nevada in 1921, there were 314 people were born in Nevada in 1921. 300 males. If I take this out, 594. Nevada population in 1920s. So if there were 45,000 people that lived in there, would it make sense for there to be about 500 people, new people born? Yeah. Wow, that's interesting. I didn't know the population was so low in Nevada. Yeah, because 500 over 43, that's like 1% of the population that was having babies. I guess 2% because it takes two to tango. All right, so this is our heat map. Is there a name that we want to look at? Maybe we should remove Puerto Rico and TR because we don't have the names going back that far. Yeah, Nevada and Arkansas. Like no one lived there back in the day. Or we had maybe, yeah, like Alaska. When did they become a state even? It is kind of interesting to see these numbers being stronger in certain parts of the state. So could we sort it by like where the popularity trend goes? So I would love to see if we go to state counts. Yeah, I'm trying to think of this. How do we do... It's like the argmax. We like want to find the max year for each state. So we can do this on a series. Okay, so like if we took the state counts and did AK, we can do argmax, which will give us the max year. That's not right. Oh, is that the index location? So 1937, so state counts. If it was a DB, I would tell you dense rank, but it does not compare to my mind immediately with Python arrays. Oh, dense rank. I've never used that before. But this is correct. Like 1937 is the highest value for the state counts for Maryland. I don't want to do a loop, but I feel like I have to do a loop because there's no data frame. Hey, Leonard, thank you for the follow. How are you doing tonight? Welcome to the family. So we're gonna create a data set, which is max years. This is each state's maximum year. We're gonna create a series with this. We're gonna sort values. Now what we have is the maximum value for each state, starting with Arkansas. And this is going to be the way that we'll order our state counts. Hold on here a second. Yeah, we should just be able to do this. What? Oh, I need to take the index of this? That's right. Now it is sorted. State counts sorted. Now we have this sorted. And let's do this same plot, but it should be a little bit cleaner looking now. We can also change the color palette. There we go. It's kind of screwed up by these states that don't exist. It doesn't have it, but so now we see like which states when their maximum year was. But some of them were just low to start with. New Hampshire and Vermont really jumped on that later. 1936, why would the name Robert become popular then? All right, let's look at a different name. What was one of the interesting ones that really spiked up late? Delilah. Let's see how this looks by state. Hey, Quaza, thanks for subscribing. What's up? Welcome back. 4 months. Should I spin the wheel? 6 a.m. data science. I like it. I like it. I'm going to spin the wheel for you. Yeah, let's do this. Living with lupus. Get rid of the ads. They're too big. 10 push-ups for you, Quaza. I spin the wheel every time we get a new subscriber, and you are the latest. Quaza's representing tonight. I absolutely love it. All right. Let's look at Delilah. The name Delilah. Hey there, Delilah. I have afternoon shifts. That would be night shift in US time. Nice. All right, so this is for the name, Robert, and this. Let's do this sorting. Do this. All right, so we made this into a function. That's right, we provided the states data frame, not df. There we go. We got our heat map for Robert, and we should just be able to do this with a different name. So let's do Delilah. Delilah. It's just a lot of nothing before the, let's look at the state's query. Year is greater than, wow, this name really wasn't that popular prior to the year 2000. I thought it was like a classic name. Interesting. I guess this is the percentage of total names in the state, which could be causing some issues. Like Wyoming, no one was named Delilah in 2019. Let's double check that. I've always been famous. Yeah, my name has been famous. Why is this not working? Okay, there we go. And name is Delilah. I can't spell Delilah. Need 2 equals. Yeah, it just didn't exist. The counts are only up to 6 in Wyoming. No one liked the name Delilah. In Wyoming. All right, let's look at Sarah. And let's look at all the years. Some states, this is like the cleanest one, I think, where you can kind of see where each state adopted the name. Let's start from 1970 on. Query year is greater than 1970. New Jersey kind of adopted it late. It was really popular in Vermont early on. Is there a trend, like geographically, Vermont to North Dakota to Montana? No. I don't think so. Okay, let's actually make this into a Kaggle data set. All right, so states to CSV. States index equals false. New data set. Baby US baby name popularity 1920 to 2022. Let's just do this. Open this up. Put Social Security website. Public. Save changes. Hi, Rob. Just joined now. What are we doing today? So I pulled all the baby name popularity, baby name data from the Social Security website. And we were looking at different names and how they were popular over different years. And yeah, like give Lemony, give me a name. And now I'm creating a data set on Kaggle based on this. But tell me a name and we can plot it. Just a random name. There we go. I love this. Thumbnail. Logan. Okay. What do we think? Logan's gonna like spike up recently, right? Show the website where I got this from. Make sure I put this in. Where did I get the top names from? Start date is January 1st, 1920. End date is January 1st, 2022. 2022. All right, everyone, this data set is up. John and Logan. Let's look up John and Logan. Love my new data uncut on YouTube. Thanks, Lemony. I guess I'll put this one up too. I thought maybe people would think it'd be a little boring to watch, but yeah, people watched it, so I'm surprised. I'm gonna maybe keep on posting these. All right, so let's plot the name Logan. Is Logan a like male or female name? Whoa! What happened here with Logan? Only gonna look at from 1980 on. Something happened in TR. Oh, what is the TR? Something weird's going on there. Does look like Wyoming had a bump for it, and also Vermont, like Logan in the early 2000s. Is there a football player? Please post more, Lemony. Okay, sure. I'm trying here. I'm trying to keep up. All right, so we have our popular baby names. I'll add this stuff later. But let's make a notebook just to ensure that we can recreate what we did here. So let's do this. Baby name popularity EDA. I'm going to pull up my notebook here on the other window and just start copying stuff over. Just setting up to read in the inputs. And then I also want to copy this plotting function, which is this. All right, so input df, US baby name popularity, name, states. And then let's plot some names. Robert, Karen. Yes, this is working. Linda. Super surprising how much Linda peaked. Delilah. And then names by state. And this is where we're going to import Plotly Express. Yes. All right. Plotly is your new love. Yeah, it is pretty. Plotly Express. It's pretty awesome. Plotly Express is pretty sweet. And then heat map of popularity by state. And let's try this for, what was the good name? Sarah. There we go. All right, so this worked. It's a data set on Kaggle. Oops. Make this back into the end. You could also add a C map. Diverging palette Seaborn. Let's see if we could find a better diverging palette. So this is actually doing it custom. What mean the last one chart? Oh, okay. So the last one chart is each state is like horizontal and each row is a year. So as time goes on for Vermont, Sarah was a popular name early on in the 70s and then became less and less popular. Hey, unnamed toy. Welcome to the family. Welcome to this. Hanging out. Is it better to always use fill in A instead of drop in A? I don't know. Did I fill in A here? Maybe that could be why it looks. Yes, that's a good point. I should not have filled an A there, I think. And then I can make this not an integer. It is looking weird where these are white. Is that because they're zeros? I don't think so, though. This creates the states count sorted. Let's return that just to check it. Are there any nulls? Yeah, this actually contains nulls. Why? Why? Because it divides by 0 somewhere? I think it's just null. I don't know. I filled in NA above, but huh. No one's serious. Oh wait. Now I want to undo. Take this out and do that. Okay, because I was returning the data frame just to check out and see how it looked. Let's do CMap is reds. And when we do this plot, CMap is CMap. Yeah, this makes it a little clearer. I think where it's white, where it doesn't exist, or the names was not even chosen once. Bradley. Oh yeah, that's CMap. Let's find a name. Query. Or how did I get in the wrong tab here? Where states equals male. This. What's up, GZT? You came just in time. Not really. That should fix your blanks. Oh, wait. You put in some multi-index from product states index levels. Oof. Maddie. Let's see what you got here. It's a really long line right there of code, but I'll try it. I'll try it. States equals. Okay, so this is not a long line of code. I just didn't split it up. My fault. My fault. Let's just see what's going on here. Multi-index from the product of the states of name and year. So this will make sure that it exists. Cannot handle a non-unique multi-index. Is a year non-unique? That's not duplicated. That's not duplicated. It's 3 lines. I could also just do fill in A as 0. Like I could go here. This. Now it doesn't have it. Now it's just like zeros. All right, so we're looking at some of the top names here. Let's look at this to the top 10. Daniel, Christopher, Mark, James. Whoa, what? Christopher got really popular in Kentucky? Let's also do this like as raw counts. It's false. We'll make a plot column value, which is going to be this. right? So now it still works, but now I can do things like this. Oh, that's because I was doing female names. There we go. This makes a little bit more sense. Christopher was popular all around. But now I could also do plot call as just count. Yeah, then it just like California just overtakes this. Everyone in California has named it, so you can't really plot that way. Ordering by largest year-over-year drop would probably undercover some. Ooh, Moomy Jumala, you gave me a great idea. That's actually an excellent idea. Then what is wrong with Kentucky with female names? Exactly. That I don't understand. That I don't understand. Let's actually see the raw count. So if I go to states, query, name is Christopher. No. That's funny. Add your name because I had highlighted it in your chat. Is this freezing on me? What's going on here? And state is Kentucky. Don't die on me now. Notebook. So the count. Why did it just go to 0 some years? Oh, that's not enough to be in the top 1,000, I guess, for female names. Yeah, so if the name's not in the top 1,000, then it gets dropped out. Should I fill in A? Like, I could F fill it. It's kind of cheating. Just assuming that the same amount as the... Oh, it's not... What's going on here? And year is greater than, what is this year? 1970? Let's find where these null values exist. No, wait. It just dropped down really low. This is bizarro. Bizarro. It's not that it dropped out completely. These numbers in this data set just drop really low. So let's go to this name Christopher. And let's actually go to this popular baby names. Change in popularity. Let's go for this name. Oh, their own website doesn't work. Oh no. Okay. Do we have time to do this? Are there years in there twice? There are. Why is that? Oh. All right, so this is the change in count by year. But we want this to be df equals pd read CSV as names. I'll take a B. It was one of the hardest courses I've taken. Yuka, what's up? Welcome to the stream. How are you doing? Sometimes I spent 10 hours a day on assignments. Well, I hope you learned a lot. I hope you learned a lot. So this is the delta. This is like the change in. Look at this. Notebook's having a hard time with it. CPU's working its heart out. Same for my machine. Let's see this. Is it really taking up that much to calculate these deltas? I guess so. So then the count, the delta over the count. Actually, we want like the previous day's count. Yeah. Let's just say that's the change. Sort values by change. And let's also make a minimum count. Query where count is at least 1,000. At least 10. Emma and Olivia became so let's see what Emma looks like. TF query name equals Emma. Sort values by year. And year is greater than 2,000. All right, let's just see if Emma passes the eye test. So the delta is how much it's going up and down. Oh, I didn't group by name and. So this is actually just showing the disparity between, no, not 6. Yeah, that's confusing. Thanks, Mumi. You caught it. So that's interesting that the biggest thing that popped up is the delta between the male and female names. All right, so let's see if this actually looks more reasonable. Okay, Elizabeth in 1990. So the thing is that this had pretty low counts. But in 1989, Elizabeth became very popular and then very quickly went away in popularity. It like 4x'd. Yeah, look at this. That's why Elizabeth had a peak. Something's going on. Bethzy in 2007? Does anyone know why these names are so changing so much? Queen Elizabeth? But this is Elizabeth? I have no idea. Unnamed was a name? I think that's just a data entry thing. Hannah. Hannah became, oh, as a male's name, became very unpopular in 2005. Let's do the counts a little bit higher to. All right, Tabitha in 1966 became really popular. It would be cool to be named unnamed. You were, I wasn't alive back then, so I don't know what. Hey, just because you weren't alive doesn't mean you can't learn about that time period. So these are names that apparently, like Tevin in 1990. Oh yeah, I also need to get the right gender, else it's not going to make sense when I plot it. Yeah, what happened with Tevin? Tevin. Does something else like back up what we're seeing in the data? I just want to be. It doesn't show Tevin having this big jump. Maybe it's like when names became on the cusp of being in the top 1,000. I don't know. Then they'll make a big jump. No, this shows it. This shows it. So it like had a big jump back up in 92. 92. That's like what we see here. Okay, so that's yeah, that's Tevin for you. All right, so we did that. We found the changes in popularity, but the notebook doesn't have it. Let's save this notebook. Let's see if I can run these 2 lines of code. Yeah, I think I'm about done here. So thanks everyone for hanging out. We took a look at names. We made a new data set. It's on Kaggle. If you want to check it out or upvote it, feel free. I'm going to save this. I'm going to also put this in here. Oh, apparently Tevin was a popular R&B artist at the time. That makes sense. That makes sense. All right, so we've combined the data so it's easier to read. We did some exploration. We created a data set. What else could you ask of for a 2-hour stream? Pretty good. What I'm going to do here is I'm going to get ready to sign off. Thank you all for hanging out with me tonight. Oh, look, this camera is here in the way. Rob, before you go, are there any learning supplements you can think of off the top of your head for R or Python? Learning supplements. I would say just try to do something with a data set. Go on Kaggle, make an R notebook, and start exploring a data set that you think is interesting, and then look up the documentation. That's probably the best way to supplement whatever you're learning in school. And it's more interesting if you pick a topic that you're interested in, right? That's my suggestion. I don't know if there's any books or anything that would be more, for me, that would be more fun than just exploring a data set. So I hope that's helpful. Any other questions? Alrighty. Let's find someone to raid, shall we? Let's find a person to raid. Software and game dev. Anyone doing Python? Somebody's leak coding. Any suggestions for who we should late? Midnight Simon is taking suggestions. All right, let's do Midnight Simon. We love Midnight Simon. He's consistent. He's smart. He's really good at talking to you all. So we're going to do the raid now. Make sure you stick around. Make sure you give a lot of hype and excitement when we raid Midnight Simon, and positivity. And I hope you guys have a great rest of your week, and I'll see you next time I stream. I'm not sure when it'll be, in 2 days or maybe on Sunday. We'll see. All right, so check out, make sure you follow so that you'll be alerted next time I go on stream. And I'll probably put this up on YouTube. So if you're watching this on YouTube, make sure you follow me on Twitch, and then you'll find out when I stream live. All right, see you all next time. I'm going to go take a nap, aka sleep for the night. Let's get this raid going. 10, 9, 8, 7, 6. Cheers. See you guys.